The topic is second derivative test. What you do first is, since you already have the first derivative from the original equation by using the power rule, which is x to n equals n times x minus 1. Now you're trying to get the second derivative, but you get the second derivative from the first derivative, which is y equals 4x to the third minus 12x. And to do that, you bring the 3 to the front, multiply it times 4x, and then the exponent you subtract the minus 1, and then you bring, for the 12x to the second power, you bring down the 2, multiply times the 12, and then subtract the 2 minus 1, which gives you y prime prime equals 12x to the second power minus 24x. After getting your second derivative, you have to find your critical points. To do that, you may simplify and factor 12x out of x minus, and you get 12x x minus 2. Then you have to set your derivatives to y equals 0. So it's going to be 0 equals 12x and 0 equals x minus 2. And your critical points are 0 and 2. But originally, from the first derivative, you already had critical points 0 and 3. So you combine those and you get your critical points 0, 2, and 3. And then after that, you have to plug in x values in between your points. By plugging in these points, you understand the parallelism of the graph, whether it's increasing or decreasing in these values. The values are x equals -1, x equals 1, x equals 2.5. And to figure out if the graph is either increasing or decreasing, you have to look at the signs of the answers you get by plugging in the x equals -1 into the x into your equation, which is 12 times -1 squared minus 24 times -1 equals y prime prime equals 12 plus 24, and it's positive 36. So on x equals -1, it's going to be a positive, and x equals 1, you plug it into your y prime prime is 12 times 1 to the squared minus 24 times 1. Your y prime equals 12 minus 24, which gives you a -12. And then x equals 2.5. You plug it into your y prime, 12 times 2.5 squared minus 24 times 2.5. Your y prime equals 12 times 6.25 minus 60. And 75 minus 60 is positive 15. And in the bottom, you can see y prime equals from positive to 0 to a 0 still to negative to 0 to positive to 0.